In November 2010, NASA announced the discovery of a strange, never-before-seen galactic object. 2 gigantic gaseous bubbles, each emanating an impressive 25,000 light-years from the center of our home galaxy, the Milky Way. Inside the structures, named the Fermi bubbles, streams of high-energy particles traveling faster than the surrounding medium collide with dust, gas, and light to create gamma rays, the most energetic form of light. Astronomers were perplexed. While gamma rays are not uncommon in space, radiation of this magnitude had only been observed in distant galaxies, and they are typically produced by large-scale, powerful events, like explosions of supernova. Yet compared to our galactic neighbors, the center of the Milky Way and the supermassive black hole that resides within it was always thought to have been relatively calm. So, what was the powerful event that created these massive structures? And is the center of our galaxy not so sleepy after all? A clue to answering these questions came in December 2020, when astronomers announced the discovery of yet another set of radiating spheres. Entitled the eRosita bubbles, these structures are even wider, extending nearly half the distance of the entire Milky Way in both directions, and fully encapsulating the Fermi bubbles. They emit soft X-rays, which have frequencies lower than gamma rays, but are still highly energetic forms of light. Astronomers quickly surmised that the overlapping bubbles most likely share a single origin, and the event that formed them must have generated a massive amount of energy, approximately 1 million times that which the Sun will produce during its entire lifetime. Based on the speed of the jets of energetic electrons within the bubbles, they calculated the event most likely took place less than 3 million years ago. This is relatively recent compared to the galaxy's 13 billion-year lifespan, and means our early ancestors might have even witnessed the powerful event as a gigantic ball of heated mass illuminating the night sky. But what exactly was the powerful event? 2 theories quickly emerged about what could have created the bubbles and the high-energy particle jets within, and both are still debated today. The first theory is that the bubbles stem from a recent massive burst of star formation toward the center of our galaxy. Newly forming stars produce a vast outflowing of hot gas called stellar winds. Meanwhile, young massive stars die quickly, causing energetic supernova explosions. Stellar winds combined with these explosions can lead to the formation of large-scale galactic winds. These galactic winds can push away the surrounding material, creating gigantic bubbles. The second theory is that the structures are the result of a powerful outburst from the supermassive black hole at the center of our galaxy, named Sagittarius A star. This black hole lives up to its title of supermassive, as it's approximately 4 million times the mass of the Sun. And scientists have documented similar jets of energy emanating from similar black holes in other distant active galaxies. These jets are found in active galactic nuclei known as quasars, and they're created as dust and gases rapidly fall into the feeding black hole. This gathers hot, ionized gas around the vicinity, which is then ejected from the center at ultra-fast velocities. This theory suggests that Sagittarius A star, which is thought to be relatively quiet, may have been active relatively recently. And it begs the question, will it wake up again? Scientists use supercomputers to run what is known as hydrodynamic numerical simulations, where different physical conditions that may have led to bubble formation are explored. While several results suggest that extreme outbursts from Sagittarius A star likely contributed to the creation of the bubbles, it remains to be seen whether past star formations may have also played a role. Other simulations show evidence of other contributing factors, like the influence of circumgalactic medium winds from outside our galaxy, which may explain some of the bubble's unique features. These computational simulations will only get more precise as we continue to launch more sensitive and dynamic telescopes into space. But whatever answers we unlock will undoubtedly lead to more surprises about our mysterious and perhaps not so calm galaxy.